Hey, 7th graders, this is Mrs. Cervantes.
And Mrs. Salati. And together we are
Mrs. Cervantes. Okay, hey, 1.3 subtracting integers part 2 is what you should be on today. So look for your yellow note taker that has part 2. Remember, there's 2 pages. I don't know about your kids. My kids are forgetting that there's an additional practice on the back. So watch the video, fill out the first page. Remember, you're writing everything we write, nothing less, but you can write more. And don't forget to do the additional practice. I know Miss Talati at the end of each video has reminded you guys to flip it over and do the additional practice.
But some of you push stop before we're done talking.
Or here's the other thing we're having problems with. Some of you guys are forgetting and not doing your homework, so then you're just solving the problems instead of watching the video, which makes it really obvious that you didn't watch the video because you were supposed to be modeling on the problems, for example, from 1.3 part 1. So you need to watch the video. You're not going to get credit if you do not have down the notes that we're giving you in the video, okay?
So this key term is going to pop up again. You should just rewrite at the top of this note taker.
All right, so opposite of a number, 2 numbers that are equal distance from 0 on a number line. These, you guys know, like she said, is review. Ooh, that's a super straight line. It's the same distance from 0 on a number line. So if I have 1, 2, 3, and I'm talking about 3, what's its opposite? It's 3 spaces away in the other direction. So -1, -2, -3. And where's it at here? And then Miss Talati showed you a little bit different. She was more in depth. She said 3 spaces away in a positive direction and 3 spaces from 0 in a negative direction. So -3 plus 3 ends up being an additive. Your pen is freaking me out. Ends up being an additive inverse, right? Equals 0. And then I want to show you guys this too, because some people are still not understanding that those are the same thing by commutative property of addition. -3 plus 3 is the same as 3 plus -3 equaling 0.
All right, so some of you guys went ahead. So it's absolutely okay, but what you did was watch the Math 7-8 video. So you kind of jumped from chips to the rule, which is why we broke it into 2. So if you guys recall in the chips video, we added in 0 pairs in order to physically remove the other integer. So now we're going to teach you just the rule, which again, some of you guys have already identified either through that video or on your own. And then we gave you the steps. So if you guys look, it says subtracting integers by adding the opposite, which basically means we are taking every subtraction problem and we are now creating an addition problem. Now listen, when you guys took your 3-minute drill or even your quick check, many of you have shown mastery in adding integers. So if we change every subtraction problem to an addition problem, then right there you're already 1 step ahead of mastering subtraction. Okay, so follow me on this. Step 1 is you're going to keep the first integer. So if we're looking at example 1, which is 8 minus 11, I'm going to keep my first integer the same. So that positive 8 stays a positive 8. Step 2 says that you're going to change the subtraction to addition. So now I have the subtraction to addition, and then it says change the integer after the now plus sign to its opposite. Well, remember when we were looking at chips, we said 8 positives, you're going to take away 11 positives. So the opposite of 11 is a -11. Okay, so again, we are adding the opposite. Now these problems, I need you guys to understand that 8 minus 11 is the exact same thing as 8 plus a -11. Well, now we go back to our addition signs. We have different signs, which means we are going to subtract and take sign of larger group. And you should be writing this down, because if you think about it, we now have the absolute values. So we have 11 minus 8, which is a 3. And because the 11 group is bigger, see right here, this would be 11 reds. Our answer is a -3. So again, if you think about it to yourself, you have 8 yellows and 11 reds. So 11 is the bigger group, so our answer is going to be a -3.
Okay, looking at the next one, following the same steps. So just like Ms. Talati pointed out, we did this in class as well. I'm going to erase that because I write big. Okay, so we did this in well. What does this mean? This means 3 reds take away 5 reds. Okay, so if we're looking at that and we're talking about using these rules and adding the opposite. Think back to our chips and you guys using the 0 pairs. So I have a -3 minus a -5. And if I'm adding the opposite, following the rules up top, keep the first integer, change the addition to, or change the subtraction to addition, change the next integer after the now plus sign or a positive sign to the opposite. What's opposite of -5? +5. And then follow your rules for addition. Am I skipping anything?
No,
you
you're
wanna
fine,
do? I
because now
said
they're
it.
different signs.
So I'm saying it a little different than Ms. Talati, just so you guys can hear it different ways. So now that you're looking at it, it's an addition problem and you need to follow your rules for adding, which is same sign or different signs. They're different signs, so what do? You subtract. What's 5 take away 3? You're thinking absolute value there, but you're really not going to write it out. So it's 5 take away 3, which is 2. And then keep the sign of the bigger group. And your bigger group, like Ms. Talati pointed out, there's 5 yellows here and 3 red chips here. So your 5 is your bigger group. So you keep it positive, and the answer is 2. +2. Okay?
Perfect. Okay, and then last one again, I'm going to write it a little bit more like Cervantes did. So if I have a 19 minus a -19, we are going to keep our first term, so the 19 stays the same. We're going to change the subtraction to addition, and we're going to change the sign of the second number. And again, we're just kind of stating it in different ways so that it might make more sense. So this problem here now, I can rewrite as 19 plus 19, which is 38. All right? So now we got one word problem. Cervantes, she's getting carried away with hand sanitizer.
Sorry, I love that hand sanitizer. Okay, Theo had a balance of -$4 in his savings account. After making a deposit, he has $25 in his account. What is the overall change? All right, so let's underline some important stuff. So he had a balance of -4 in his savings, and then after a deposit, he now has, so after making a deposit, he now has 25. What is the overall change? Okay, so some kids did this on their homework in Math 7-8. They just did -4 minus 25, and their answers were all wrong, and they were confused why they were wrong. So if we're talking about what is the overall change, we're talking about change, thinking about it in the way of saying difference, and what sign represents finding the difference? Subtraction, right? So if we're subtracting, they did -4 minus 25, and that does not work because that gives you a negative answer, and then they all wondered why they had a negative answer. So you always have to find the difference between, no, sorry. I did it wrong. I'm doing geometry from last night. So where you ended and where you started. Okay? So write these notes down. Where did we end? He ended up with $25 in his account. And where did he start at? And I'm going to use parentheses here to differentiate between my minus and my negative. So then he started at -4. So now if you're following your rules, not using your chips, and the first step is to keep the first integer, change your subtraction to addition, and then change your next integer to the opposite. The opposite of -4 is +4. So what was his change? And then think of your rules for adding. These both have same sign, so you add and keep. So you keep it positive, and it's $29, okay? The other way we talked about thinking of this was like a temperature, a thermometer,
Yes,
or a number line. We'll
yeah.
do it this way since we have room on here.
That helped those guys today.
If we're at 0, and let's say 25 is up here, and let's do -4 down here. When you're asking how much did it change, so if he had -4 and he ended up with 25, you're asking what's the difference between 25 and 4. So it's all of this here. So from there to 0 is 25, if you're following me. From here to here is 25, and then 4 more. What's 25 and 4? 29. So he changed $29.
Perfect, because I think the number line was what really helped. Yeah, helped those guys
Yeah, you
today.
guys can do your number line horizontally too if you want, if that helps you visualize better too. Okay, you have your additional practice, my class. I don't know if Ms. Talati is struggling with this, but my class, do not forget to turn your page and do your additional practice. You do not have to use R's and Y's or chips or model on these ones. We're just using the rules. Watch the rules.
And what we want to see, you guys, is you can even write them to the side. So if we go, you can do it one of two ways. Keep, change, or actually write it as a new problem and then solve it.
Yeah,
We need
perfect.
to see you utilizing the rule though on this one.
Don't try to do it in your head. We should not just see this. Write it the way Ms. Talati did it. We should not just see this on your paper. And answers going all the way down, okay? I almost gave them more answers. Okay.
All right, you guys. Have a good day.
Bye.